All right, everybody, welcome. We're back here Tuesday night, 8:30 Eastern Standard Time. This is Dr. B. If you're new with us, if you've been here, I see some familiar names. I see Mia, Min, Igor, a bunch of other folks. Say hello in the chat so I know who's here. Looks like we've got a few people coming in now. And tonight, we're going to talk about learning something difficult. How do you learn a really difficult topic? Because we come across that a lot in chemistry, where we have these kind of more challenging than other courses, is usually what I hear students say. So let's do this. Let me jump over here to kind of my table of contents. And where is it? There it is. All right. There's Catrix here, Thonnot, Andy's here. Hey, Andy, good to see you. Isabella, Kanishka. Wow, lots of folks. And it's night right here, and we actually had snow today, which was kind of cool. So it's getting cold and the days are short. So here I have learning hard topics, and I used this AI generator, Midjourney, to make a picture of two mice balancing redox reactions. Hey, Loretta. So this is what it came up with. These are two mice balancing redox reactions. And it's quite confusing. I'm not quite sure what those mice are doing there. I can see the balancing thing, but I'm not sure what's going on in the center here. So anyways, when you're learning something hard, it kind of feels like that at first. You might see some of the patterns, but there's a lot of things that just make no sense. And then the really creepy thing, I don't know if you've seen it in the image. There's something really creepy about these AI generated images. Take a look. It's this mouse right here that's having the problem. I'll zoom in on it. It has 3 feet, 1, 2, 3. So it looks like a pretty decent image, but the AI, it really does not always do things correctly. Mice don't have 3 feet. Anyways, so does its tail branch? Yeah, this, I think this is its foot here. That's what I'm thinking. This one doesn't seem to have a tail, now that you point that out, Nubius. Huh, okay. So yeah, let's do some chemistry here. Learning hard topics. So we're going to go over these, and hopefully by the end, you'll really be in good shape for dealing with hard topics. So the first thing that you have to do is you have to be able to identify, what your big goal is. And realistically, our big goal is probably to do well on the exam, if we're honest about it. But in the case of redox reactions, we want to balance atoms and electrons, or charge. So you almost want to get that big idea and write it on a piece of paper and stick it on the wall and keep going back to the big idea. Just keep going back to it. And we also want to know about oxidation and reduction too. So if you're really into pH, not pH, this one got me thinking about pH for a second there. If you're really into pH, on my website, I just did a big guide on redox reactions and how to do each step in the redox reaction. So jump over there to breslin.org.redox and you can find all of that stuff. Okay, so I want you to think about your memory and your mind for a minute. So when we think about how our brain stores information, you learn something new. You encode it into your memory. And we've talked about this before. So that's one part, but then you've got to get it back out. So you're sitting in the exam, you're thinking back to when you studied. You've got to pull that memory back out and answer a question on the exam. So which one of these images right here do you think would be better in terms of like a model for your brain? This one, let's call this A or B. Which one is a better model of what your memory should be like? And these are both generated with the same AI. I did the three-legged mouse. This is a little bit better here. So think of it this way. If you store a memory, yeah, and Igor, you're talking about the connections, right? If you store a memory, say this big idea that for redox reactions, we balance atoms and electrons. So say you store that memory right here. if you associate other memories with it and they're linked, you might have to retrieve, you could retrieve this, pull that back out, but then you can kind of link into these other memories. And once they all become linked, it's much easier to retrieve memories and they come back out much quicker. And down here, you might get this memory, but this little group, you can't link to it. So we want to create linkages and we want everything connected. That's how you learn stuff and you really remember it. And on the exam, you really pull it out of your brain. So let's try one. Let's create a linkage here in our memory. How about this? I'll do the first one and then you do the second one. So I'm going to model how to do this and then you'll do the second one. What I want to know is what's oxidized and what's reduced up here. And this is the way I think about it. So the charge and the oxidation numbers are the same for this one. Kind of nice. I find the number that gets smaller. Whoops, that doesn't go there. There we go. So I know that this is getting smaller. 2 plus to 0, it reduces in size. It's smaller. That's reduction. And here, that has to be oxidation. So give this one a try. Figure out what's oxidized and what's reduced in this reaction. And I wrote the oxidation numbers for you. Give that a try. So remember, reduction, we have the oxidation number gets smaller. In oxidation, it gets bigger. And it all goes back to balancing atoms and electrons because these numbers are telling us the transfer of electrons here. I don't see anybody kicking out any great ideas in the chat, so I'll give you some help here. If you go to +7 to +4. That's right. You got it, Kartik. That's been reduced because the number got smaller. In fact, to get reduced, right, it had to get some negative charges. So it got 3 electrons and that reduced it. So reduction is the gain of electrons. And then, of course, the sulfur, that's oxidized. All right. And it lost the electrons. We always have them together. Yeah. And Taylor, if you go to my website, breslin.org/Redox, I just built a huge guide on Redux. It took me like a month. So if you're really into Redux, there's some real good videos and stuff. Maybe in the description too. All right, so we've identified the goal. We've identified the big idea. Maybe we wrote it onto a big piece of paper so we don't forget it and we're relating our ideas back to it. That's going to make those connections form. And then once those connections form, your memory pulls it out quicker and you don't forget things as easily. So now we're going to break it down into steps. So let's do that. Let's break it down into some steps. So here you go, Taylor. Here's the link. So these are the steps for doing oxidation, redox reactions. And it's really a pain in the, it's really quite involved. So everything's over here on breslin.org/Redox. But what your teacher should be doing is helping you break down these complicated ideas into manageable pieces. Because when you start learning something, you can't learn all this at once. Your brain just can't do it. You've got to maybe start with oxidation numbers, get those right, practice, learn how to write half reactions, and then learn how to balance them. So your teacher should help you do that, or your textbook, or, you know, on my website, in this case, there's some things that can help you. So always seek that out, how to make things, break them down into manageable chunks. And actually, let's go over to breslin.org here real quick. Oh, and I meant to tell you at the top of the chat, there's a poll. This is the poll. If you could do that poll to tell me what you want to see, I would appreciate that. All right, let's just go to breslin.org. I'll show you this here. So here's something where you might want to practice. So you go finding oxidation numbers and you want to find practice that has the answers too. So here's 40 problems with the answers, and then each one has a video. So something like that's really going to help you practice. All right, so let's see where we're at. Yeah, so when I talk about the examples, that's what you really want to do, is you want to get it broken down, and then you want to do so many examples that until you're just getting it perfect. So when I have my students, let me get out of here. Where am I at? There, I'm gone. I tell my students to look at an example, try it, see where they got stuck, look at the solution, and then try it again and get it right, and just keep doing that. So why don't you guys try this here? I have the rules. See if you can find the oxidation number on the chromium here. That's a challenge. I'll give you some hints here. Yeah, there's got to be some balance here. You're right, Igor. Oh, Nisrin's on top of things. All right, so here's the way I would think about it. So I'll give you an example here, and then you can do another worked example for that. So all the oxidation numbers add up to the charge on the ion. And you might get stuck here because you're like, what is this 2 minus? The negative after the number, that tells you the charge. So that applies to all of these oxidation numbers here. They have to add up to this 2 minus. Oxygen, -2. And we don't know chromium. So I like to set up just an equation. 2 times x. 8? No, not 8. 2 times x plus 7 times -2 equals the charge, which is, we're going to call -2. So 2x minus 14 equals -2. And so 2x equals 12. X equals, like Nisrin said, 6. Learning biology and chem at the same time, yeah, that'll wear you out. So you can see, you follow the rules here, and we get the answer. So I'm going to give you another one to do. Now that you've seen a worked example, you might be able to do this. And if you follow the process over and over, let's do MnO4. That's a great one. Minus, and that's a 1 minus. Think about what I just did. See if you can do that. I see what you mean, Kartik. Yeah, and when you're trying to do them quick, it's easy to make mistakes. Yeah, Javid, I'm only live on Tuesdays, and I was doing it Tuesdays and Thursdays, but I've been just working on other stuff, and I did this big Redox guide, so I'm only Tuesdays right now. But I was thinking about doing some longer stuff right before final exams, which is coming up pretty quick. So maybe I'll do that. Is it +7? That's a good question. So remember that this 1 minus here goes to everything. So all of that equals the 1 minus. I'm seeing a lot of +7s. Maybe I don't need to do it. X plus 4 times -2 equals -1. X minus 6 equals, is that right? Oh, 8. Goodness sakes. X plus a -8 equals -1. So X does equal a +7. You guys got it. And you're right, Igor. Oxygen is -2, except if it's in H2O2, peroxide, or fluorine, because fluorine's really electronegative. So that'll change the oxidation number of oxygen. All right. So do lots of examples and really do it like this process here, where you look at an example, you try it, see where you got stuck, ask the questions, really try to figure it out, and then look at the solution. Once you see that solution there, do that same problem again until you get it right. And that's really going to work well for you. So find a good set of questions to practice with. And that's kind of what your teacher should be doing too, helping you get those sets of questions to work with. Oftentimes textbooks will just give you the answer, which is really frustrating, right? If you can't figure your problem out, and it's just an answer, sometimes that will push you over the edge when you're trying to get ready for an exam. So what will be the oxidation number in, so if you had, Kartek's asking, so like if you had OF2, fluorine's always -1. So here, oxygen, OF2, so that's always going to be -1. That'd have to be +2. Is that right? Yeah, I guess that's right. So kind of weird, right? How did I know the initial -1? It's actually in the rules right here. So you would have to have memorized or have access to these rules that fluorine is always -1. That's because it's the most electronegative element. It's always going to take the electrons. Kind of goes back to that big idea about atoms and electrons. We're really thinking about electrons with redox reactions. Fluorine is always going to get the electrons. I do have a lot of videos on stoichiometry, really good videos. Go to breslin.org, my website. See if I can find just go to the first part of this, breslin.org right here. And I've got really good stoichiometry stuff. I worked really hard on that. Oh, you can't see it though. There we go. Sometimes I forget to change my screen. Y'all got to keep me honest. Oh, and H2O2, Kartek's asking about H2O2. In this case, for H2O2, because hydrogen is always +1, oxygen has to be, how does that work out? So +1, yeah, oxygen has to be -1. So it's just an exception to the rule. Lots of rules. That's what makes this so hard. All right, so test yourself with exam questions, and we'll probably kind of wrap up with this here tonight. I got my flu shot today, my vaccine, so it's making me a little bit dumber than normal here. Test yourself with exam questions, and so you've got to figure out where to get exam questions from. So for AP, you can actually go get past exam questions. I'll put those in the chat for anybody taking AP. Even if you're not taking AP, these are kind of interesting to look because they've got the solutions and they explain how they score all of it. For like stuff like MCAT, if you look around, you'll find past exams on the web, probably not legally, but they're out there. So for all of these things, and your teacher should help you with past exams too. That's the best way to study and work problems. When I create my guides, I try to create guides that have exam-like questions that you'll see in general chemistry. So always try to get those past exams and look around for them. And if you get them, share them with people. Other students, web forums, even books. You can get books of past questions. That's a great way to study. Yeah. Chemistry, the craft of exceptions. It's true, like in physics, you don't have that many exceptions. In chemistry, but you can learn from the exceptions. That's what's so interesting. So we've identified our goals. We've got an overarching idea. We broke it down into steps. We're doing examples, getting exam questions. The last thing you really want to start doing is teach someone else. So we go back to our AI image generator, and here's a picture. I'm not sure, which rabbit do you think I would be? Would I be this guy over here, the rabbit on the right, or the rabbit on the left? And they've got some interesting chemistry stuff. I don't know what this thing here is, but they've got some pretty cool chemistry stuff. Thank you, Parth. And Delicate, I don't do biology, unfortunately. I was going to be a biology major in college, and then I just got involved in chemistry. So I think if I'm going to be a rabbit, I'm going to be this rabbit right here on the right. I think that's the rabbit I would be. And maybe this is, I don't know, the right. Thank you, Delicate. Exactly. Um, yeah, maybe this is you. I don't know. Anyways, on the right, it looks more genius. Thank you. It does look like it knows a little more that what's going on for some reason. Maybe the ears are bigger. I'm not quite sure. Um, so we really don't have a lot of time here tonight. I'm going to, where am I at? Here I am. Next Tuesday, I was thinking about showing you how to use some of these AI text generators to create exam problems. So potentially I'll try to do that and then do some more chemistry. But in that poll that's at the top of the chat, tell me what you want to see. I'm always interested in your ideas and any way I can do better, because this is probably like my 25th stream, but it's not like teaching in front of a class where you see everybody's faces. It's a little bit more kind of isolated in a way, I guess I would describe it. So yeah, and Daniel, excellent. I'm glad to hear that you'll teach, but you can teach people now too, especially if you get really good at one thing. Like if you get really good at Redox, and you can balance any redox reaction, you would be like a much sought after tutor, I think, in chemistry. Competition. Does the glass egg have an opening? It does not. So I don't know, maybe it's some kind of weird ecosystem vessel. Yeah, Alex, I agree. This one is kind of like it's kind of like checking its answer almost, maybe it seems. And Nubius, that's actually shadowing your chem TA is a good idea and seeing just what they're doing. Yeah, there's probably something weird. Like they do have pause in here. It seems like most of they don't have 3 ears, so that's good. Looks like most of it's pretty reasonable, but I'm sure if you looked at it for a while, Igor, you would find something probably equally creepy going on. All right. I think that is going to be it for me this evening. I appreciate everybody joining me, and I hope you learned something about how to learn things that are difficult. And that extends not just to chemistry, but that extends to things like, for me, learning to do streaming is very difficult. And some of those same things, looking at examples and looking at how other people have done it, working with other people, really helps you grow and be better at these things. So I hope everybody has a great night, and I will see you back here next Tuesday at 8:30 Eastern Standard Time. This is Dr. B. I'll stay on chat for a bit afterwards, but thank you for watching.